In this experiment, we tested the principles of standing sound waves and tube resonance. We had 5 different bottles, all with different lengths and shapes. We blew air over the top of each bottle. While doing this, we had a sound spectrum analyzer app on our phones. This allowed us to measure wavelength, frequency, and the speed of sound. First, we measured the length of 5 different bottles. The length and shape of these bottles were altered to see how this would affect the measured wavelength, frequency, and speed of sound. Measuring the length of the bottles gave us the wavelength of the sound produced. This can be determined by the equation seen on the screen. L represents the length of the bottle. Lambda represents the wavelength of the sound. The opening, aka top end of the bottle, is where air can move freely. This is referred to as the antinode. The bottom, aka the closed end of the bottle, is where air cannot move. This is referred to as the node. As you can see from the diagram on the screen, the distance from a node to the antinode, the length of the bottle, is only 1/4 of the wavelength. The measured lengths and wavelengths for each trial are shown in this table. The calculated wavelength and velocity was used to determine the frequency. The equation on the screen was utilized. In this equation, V represents the velocity of the sound, F represents the frequency of the sound, and lambda represents the wavelength of the sound. At room temperature, sound waves travel at 340 meters per second. So this velocity will be kept constant for the frequency calculation throughout this experiment. The calculated frequency for each trial is shown on the screen. As you can see from the table, the longer the wavelength, the lower the frequency. The shorter the wavelength, the greater the frequency. A low frequency produces a deeper sound, and a high frequency produces a high-pitched sound. The calculated frequencies were then compared to the observed frequencies in the Spectrum Analyzer app for each trial. What you just seen in the previous video was repeated for each bottle used in the trial. As you can see in the table, the observed frequency was pretty close to the calculated frequency for each bottle used in the trial.